Hello everyone. So in this lecture we are going to learn about one of the most popular problem in computer science, that's Tower of Hanoi. It's one of the main application of recursion, right? So first let us understand what is the problem and what is the solution. How can we give the solution? It is the application of recursion. So basically you have a pole. This is like pole A, pole B and pole C. So this pole A is your source, pole B is your destination, and this you can use as a auxiliary. Now what is a problem? That you have a 3 disk of different size, a bigger one, a slightly smaller one, and the smallest one. You need to transfer this, you need to move this from source A to the destination C. All this ring you need to transfer from this pole A to pole C, that's from source to destination, but one by one, right? Also you need to maintain the same order. So at the end you should be have like the larger one, then the bit smaller one, and then the smallest one, right? So this order, same order should be maintained, right? At a time you can move only one disk, that means single disk only you can move. And the third condition is at any moment, at any point of time, there never be the larger disk come upon the smaller disk. There is always smaller disk must always come above the larger one, right? So smaller above the larger, right? At any moment, that is like if for the biggest one the smallest one is residing upon it, that's correct one, right? We can have it, right? But never it should be like the smaller one and then we can have the bigger one. No, this is not the correct one, right? So while maintaining all these 3 criteria, this 3 condition, that we need to move only one disk at a time, there is always a smaller disk above the larger one, and we need to transfer from source to destination from A to C in a same order, right? That is the problem we are having of Tower of Hanoi, right? Now how can we give the solution of that? So suppose like we are having n is equal to 3 for the 3 number of disk we are doing it. So let us say we have this, this is 3 poles I am having, right? So A, B and C. So initially I have like this is my disk number 1, 2 and 3, right? So what I can do is, for the first step, I'll move this first disk to C, right? So that means the smallest one, the first disk, I am moving it over here, and here I am having my third one and the second one, right? This is the first step. Now on the second step, I cannot move this 2 towards the 1, because if I do so, then there is a violation of rule, because this bigger one can't be on the smaller one, right? So I'm having only one option, that I can move this 2 to the B. That's my auxiliary, right? So in the second step, what I'm doing, here I'm already having my 1. This second number disk I'm moving towards 2, right? Now in the third step, what I'm going to do is, I can move this like 3. I cannot move on 2 or on 1, so I cannot move 3 to B or C, right? If I move C towards A again, there is again no issue. To B, this 2, I can move it towards either 3 or a 1, right? So what I'm doing as of now, that I'm moving this disk to the B, right? So it's like a game, that pole game the children used to play, right? So like A, B and C. So I'm having number 3 over here. Here I am having number 2, and on that I am having number 1, right? So there is no violation of rule, as I am transferring this smaller one is above the bigger one, right? So no violation of rule. So as of now I am having this. Now what I'll do in the next step, I'll keep it here, okay. And the next step, I'm transferring this third one from source to destination, right? So that is here my third disk, right? That's a C. And here B, it will remain same, like 2 above that 1. Now my A is empty now. Now what I'll do next, I can move this 1 over here, but then again there is no use of it. So what I'm doing, I'm transferring this 1 to A. So here I am having the bigger one 3, the middle one 2nd, and this one smallest one I'm transferring to here, right? A. Now next what I'm doing, I'm transferring. Now you might get an idea, like this is very easy, right? To transfer this 2 to this, right? So this 3 I am having over here, right? So I am transferring this 2 over here. This B is empty, A is still having this 1, right? So in the last step, what I am doing is, this 3 is here, this 2 is here, and the last smaller one I'm keeping over here, right? So this is A, B and C. As you can see that here I am having in a source this order 1, 2, 3, right? Same order 1, 2, 3 I am having it in my destination, right? So this is the solution of Tower of Hanoi, right? That is for n is equal to 3, right? So for 3 numbers we have 7 steps, right? What if we have more numbers, right? If we have 4, right? So it's actually 2 raised to n minus 1, right? 2 raised to n minus 1, that means my n is 3. 2 cube, that's 8, right? And 8 minus 1, that's a 7. That means I'm getting my answer in 7th step, right? The rule is 2 raised to n minus, it's 2 raised to n minus 1, right? So that's a 2 cube minus 1, that's a 8 minus 1, so 7. So we are getting the answer in 7th one, right? So I hope you understood it. Now in this, if you take a closer look over here, so in the third step, this one is important to understand the logic, right? If you want to understand the logic of the algorithm, because we are using the recursion, right? Recursion means function calling itself, right? So here as you can see that on the third one, I'm having my two disks at auxiliary position, right? So that means 2, that is for number of n is equal to 3, I am having n minus 1 disk at my auxiliary position, right? So that is important task, right? Then what I am doing, that I am transferring, the fourth one is also important because I am transferring the nth disk from my source to destination, right? So that is one more thing, right? And then the last one, as you can see that here I am having n minus 1 disk in the B, right? So I am transferring that from the B to C, the seventh final step, to C, right? So that is n minus 1, right? So if we talk about the algorithm, right? So algorithm consists of only 3 steps, right? So 3 steps. The first step is move n minus 1 3, right? I told you that this step number 3, right? N minus 1 ring, right? From source to auxiliary, right? So we are transferring it from A to B, right? Or else you can directly have this from source to auxiliary, right? Then the next step, what I am doing, that I am transferring the nth ring, right? That is left it over here, right? I have transferred n minus 1, so one ring is left there on A, so I am transferring that from A to C, right? Directly you can see this over here, right? From A to C I have transferred that, right? And then the third one is the rest n minus 1 that I have transferred to the auxiliary, right? So move n minus 1 rings from B to C, right? From B to C. Now what will happen? I am transferring this from B to C. So now this B will work as a source. This will work as a destination, and using what we are going to use A as auxiliary, right? So that's what we are having, right? So it's a concept of a recursion, right? So in 3 steps only I am getting my answer. This is the algorithm, that move n minus 1 ring from A to B, move nth ring from A to C, and then move n minus 1 ring from B to C using A, right? So this is my recursive case. Because as you know that recursion always consists of 2 cases, right? Base case and a recursive case, right? So if we have a base case, so this is like this 3, 1, 2 and 3, that is recursive case. And if we talk about a base case means what? The single one, right? Not if there is no recursion, right? So that if my n is equal to 1, n is equal to 1, that means there is no recursion, right? So directly at that moment what we need to do, we need to directly transfer the ring from A to C, right? So move the ring, because it's always a single ring, then only it comes for n is equal to 1, right? So move the ring from A to C, that is source to destination, right? And we can use B as auxiliary if required, right? If required we can use B as auxiliary, right? So this is a very popular and a classic problem of data structure, or you can say computer science, that Tower of Hanoi. So if you are a computer IT engineer, if you are interested in it, so you must know that anyone can ask you what is Tower of Hanoi, right? You should be able to answer, right? So yeah, this is about Tower of Hanoi, and I hope you understand it, right? Thank you very much.